Okay, so let's start on that very first math lesson. We're going to talk about numbers, numeracy. Okay, what are natural numbers? Anyone? Natural numbers. You want us to read it? Okay, as if you pretend that you don't see this. Okay. Positive numbers, good. All right, what about whole numbers? What's the difference between natural and whole? Oh, sorry, Aveen? Zero, right. So only difference between these two is whole numbers have zero. Okay? Are whole numbers part of natural numbers? No. But are natural numbers part of whole numbers? Yes. Okay, you can see this set appears here. So natural numbers are also whole numbers. What about integers? Derek? All numbers including negatives. Including negatives, right. Right. So whenever you know it, whenever you see a negative numbers, you know that it cannot be a natural or whole. Right. What about, so now those are pretty straightforward. Now rational and irrational, those two are the more tricky one. What are rational numbers? Eric. It's a number that can be written as a fraction in infinite ways. Good. Okay, so you can write it as a fraction of integers. Okay, that's one way. And the second way to tell that it's irrational? No. Yep. It cannot be divided as irrational. Sorry, repeat that? Okay, so one way to tell that it's a rational number is if we can write it as a fraction of integers. So like 2 over 3, 3 over 8, 7 over 9. So as long as it's integer and we can write it as a fraction, that's a rational number. What's another way to tell that it's a rational number? There's 3 ways to tell. Okay. Terminating decimal. So I can have like numbers like 23.457. Okay, it's an ending decimal. That's also a rational. 0.0042878256513. All right, the decimal ends, so it's a rational. But what if it goes on forever? It has to be a repeating decimal. If it's a repeating decimal, then it's also a rational. Okay, so 1.66. So for example, 1.6666. It can also be written as a fraction. Anyone know what this fraction is? 1.6666. Eric? 1 and 2/3. 1 and 2/3. Or as an improper fraction, 5 over 3. So it's 5 over 3. It can be written as two fraction of two integers, and that's why it's a rational. Okay, this right here, what about this? Why is this a rational? Why is this example a rational? Yeah? Right, the 2, 5, 6, 7 repeats. 2, 5, 6, 7, 2, 5, 6, 7, 2, 5, 6, 7. So that repeats. So that also tells you it's a rational. Okay? So what's an example of an irrational number? An example of an irrational. Genevieve? Genevieve, sorry. Pi, right? So the famous pi. All right. Who can tell me some digits of the number pi? Okay. Cool. Oh, okay. Who can beat that? Oh, okay, Eric. 3.14159653589793238466279382379502883419716939937510. Even if he made a mistake, we wouldn't have catch it. We wouldn't have known. So good for you. Wow, much more than I can remember. Uh, do you think you need to memorize that for the test? No. Why? Yes, you get a calculator. You get to use your calculator. So all calculators, scientific ones, will have this button. So you can just use this button. Okay. So much for memorizing, but good for you for remembering. If you don't remember any of those digits that he said, you can just use the pi button. Okay. Yeah. So as Eric demonstrate, it goes on forever and it doesn't repeat, and so that's why it's an irrational number. Okay. And all these belongs to the real number set. Right. So all this is within the real number. Um, what's the opposite of real? Unreal. Yeah, but that sounds so fake. Yeah. Imaginary. See, doesn't that sound so much more specific, like mathematical? Yes. So this whole set belongs to the real number set, and opposite to it is the imaginary numbers. Yeah, on the outside of it. Okay. Do you need to know the imaginary numbers? Okay, but it exists, but you don't have to worry about it until grade 11. Yeah, so you don't learn about I until grade 11. Imaginary numbers are like square root of negative numbers. Those are imaginary. So in grade 9 and 10, we just focus on the real stuff. Okay, so let's do some examples together. List all the sets that belongs to each of these. So 4.5. So 4.5, is it a natural? Is it a whole? Is it an integer? Rational or irrational? Who knows the answer? Vincent. Rational. Rational. That's right. Okay, 4.5, it's a decimal, terminating decimal. So it's a rational number. What letter do we use to represent rational? Q. Q. Yeah, I can totally see the letter Q in the spelling of this. Right. Okay. So when we write sets, we do this squiggly line to show it's a set, and we write Q for rational numbers. It also belongs to another set. Other than Q, what do we say all numbers belong to? Yeah, real. So you have to write both rational and real. Because when you get into grade 11, we get into the imaginary, and I don't want you guys to forget about real. So it's good habit. Okay, B, negative 3 over 8. What type is this? Not everybody at once. It's a fraction of integers, so it's rational or irrational? Rational, right? Because you can write it as a fraction. Yes. So it's Q and R. Oops, sorry. 25. What type of number is 25? Derek. Integer, whole, natural, and real. Perfect. So actually, it's you missed one. So natural, whole, integer. What else? Is it a rational as well? Yes, and real. So because if you look at this circle diagram right here, 25 is right here, and you can tell that this circle is inside this circle, inside this circle, inside this circle, inside this circle. So it's all of these. Okay, 0. Okay, Derek? Whole, integer, rational, real. Right. whole, integer, rational, and real. Right? 0 is right here. Right? Notice it's outside of the natural, but it's within all the other circles. Okay. Root 4. Square root of 4. Other than Derek. Thank you for your participation, but the others, give others a chance. Arvin? Perfect. But root 4, why is it a natural number? Right, because square root 4 is just 2. Okay, so just because you see that square root button doesn't make it irrational. You have to figure out what it is. And it's actually just 2, which is the natural. Okay, but what about root 6? Sophia? Irrational and real. So for irrational, we use a Q and a line above to show it's irrational. So like out of all the 26 letters in the alphabet, they decide to use a Q and a line above. All right. 2.11111 repeating. Genevieve. Right? Rational and real because it's a repeating decimal. Good. Okay, remember right here, if it's a repeating decimal, it's rational. Okay, 2.1. Eric.
Rational and real.
Why?
Because 2.1 can be written in an infinite amount of ways in fraction form.
Okay, and what type of decimal is it? Terminating, right? Okay, so these are the type of communication question you might see on the test. So other than just giving the answer, you might have to explain your answer as well. So why is 2.1 rational? Because it's a terminating decimal. All right. 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. All right, Sophia.
Irrational and real.
Irrational, that's right. All right, pattern. Are patterns repeating decimals? No. So I see a pattern, but that's not part of the definition. Right? So for rational, it's just repeating or terminating. So it's not repeating. It has a pattern, but it's not repeating. Eric? Oh, sorry, not Derek.
Rational and real.
Right. For pi, that's the easiest one. So you have to get this one right. Irrational and real. Okay, very last one. Somebody who hasn't participated today. Negative 780. Someone who hasn't participated. Yes, see, I love the encouragement. You wanna, okay, Hannah, you wanna give it a try?
It's okay.
Is it?
It's irrational and an integer. Oh wait, no, sorry. Rational, integer, and real.
Perfect. See, that's why we all have faith in you. Thank you for the encouragement, Alvin. So it's negative, so I know it's an integer. And looking at this, I can see an integer is within the rational and it's a real number. Okay, so I, Q, and R. Okay. So I'm gonna give you guys some time to try it on your own. Page 3. So try this page. Let's spend 10 minutes. Okay. Try these ones right here. 10 minutes. And then we'll talk about this. Okay. So you guys had a chance to do page 3. Don't forget answers are on page 4 for you to check to see if you understand it. If there are ones that you got wrong, feel free to put up your hand later on and ask me why is it this or and so forth. So I just want to go over this last question on page 3 really quickly. Anybody know the name of this diagram? Vincent?
Venn diagram.
Venn diagram. Yes, it is called a Venn diagram. Okay. And so it means that this part of the circle are integers, this part of the circle are whole numbers, and then the middle of it, the overlapping part, means that numbers that are integer and whole numbers. So negative 0.462, is it an integer or whole? Eric?
None.
None is neither. So where do I write it if it's neither? Outside, right? So negative 0.462. Right? Negative 56. It's a negative whole. It's a negative integer, so it's a right. So it's an integer right here. So negative 56. All right. I don't know why it's so dark. 735. Yep. In the middle because it's a whole number and it's also an integer. So it's in the middle right here. So I'll do that. 735. Right? 0.326. Claire? 0.326?
It's none.
It's none, so you write it on the outside. 8,321. Where do I write that? 8321. Yeah,
In the middle.
right in the middle. And then lastly, 0. Yep, middle. Good. Okay, so that's a Venn diagram. Venn diagram could be with numbers. It could be with other topics as well. This is a quick little intro to Venn diagram because in the last EQAO I did see one question where they gave a Venn diagram. Okay, Venn diagrams, does it have to be just 2 circles? No, yeah, it could be 3 circles. It could be 4 circles. So yeah, but the concept is the same. Okay, so I just want to do a little bit more on page 5. So sets and subsets, we talked about these. So for number 1, state the number of elements or member in each set. All it means is how many numbers are in there, basically, or how many types. So for the first one, blue, green, red, yellow, how many types are there? 4. That's all. So hard. Okay, what about 2, 5, 6, 8, 10? How many numbers are there? 5, yeah. All right. 0. 1. Yeah, that's it. Okay. You can have that empty set as well. So this is an empty set. So we can write none. Okay. Oh, what about this one? 1, 2, 3, 4, 5, there's 3 dots. I mean, it goes on forever. Infinite. Right. Because it goes on forever, you can actually have infinite number of numbers in that set. Okay. Let's just do number 2 really quickly. Explain why 7, 9, 12 is a subset of this larger set. Derek?
7, 9, 12 are all numbers in the larger set.
Perfect. Yeah, that's all it is. So you can see that 7 is in there, 9 is in here, 12 is in here. So that's why this is called the subset, and this we'll call it the parent set. Okay. Okay. And then let's do this one. 5b. The set of odd integers from -5 to +5. Okay, so remember, whenever we write a set, we have to do the squiggly line to show that as a set. And yeah, Derek?
-5, -3, -1, 1, 3, 5.
Yeah, that's it. 1, 3, and 5. Okay. And when you list the set, you just put a comma in between. Okay, and then last one, number 6. This is all the subset of the set 1 and 2, because this one is a little tricky. Sophia?
1 is a subset and 2 is a subset.
Okay. And Vincent, you want to add to that? Were you going to say the same thing?
Yeah.
Say the same thing? Okay. There's actually one more. Yeah, the empty set. Yeah, you can actually have the empty set as well. Okay, so that's why I said this one is a little tricky. Okay. So I think we got through all. I'm going to give you the rest of the class time to work on the ones that I skipped up to page 6. So homework is up to page 6. Okay. What was yesterday's homework? Did we have homework yesterday? Right, how to use Brightspace quiz. Okay, so I saw that some of you guys haven't done it yet. So remember on Brightspace, that's not worth marks, but I just want to make sure that you guys have access to Brightspace. Those who weren't here yesterday, I'll show you guys in a second. And then tonight's homework is up to page 6. And because I want you guys to get onto a great start and good working habit, I am going to do homework check tomorrow. Right, so I'm going to do homework check to see if everybody has done up to page 6. Sounds good? Okay, so that's all for today's lesson. And see, my recording is 22 minutes, just like how I promised. And you have rest of the class. You have a good 20 minutes right now to finish all the homework, and then you have nothing.